This is Unit 4.6, Watersheds. You might have heard of the Chesapeake Bay watershed, since that's the watershed that we live in. And Chesapeake Bay is one of the most important, ecological areas in the U.S. It's a fairly large bay, and consequently has a fairly large watershed, as in any drop of water that lands within the area that's highlighted here eventually makes its way to the Chesapeake Bay. And you can see it's a pretty large watershed, right? Most of Virginia, nearly all of Maryland, even parts of West Virginia, a large part of Pennsylvania, and even up into New York. Right, water that falls in some of central New York eventually makes its way to the Chesapeake Bay. Um, so when you talk about the Chesapeake Bay, it's not just Maryland, right? We have to coordinate with parts of Delaware, PA, New York, Virginia, even West Virginia, in order to keep the health of the Chesapeake Bay high. So how this kind of works, like if you see a river on a map, you should notice that it always flows in the direction of the V's. So you notice that these sort of first order tributaries, those are the number ones, right? They make a V. That means the water is flowing down toward the V. And then they come together in the second order tributaries, which make their own V's down to the three and then the four. So make sure you always know which direction the water is headed. It's not always obvious. And, you might have heard that some people think that rivers always flow south. Yeah, it's not always true, right? So rivers flow downhill generally. Right, so characteristics of a watershed. We're going to look at these 6 characteristics and how they determine like types of watersheds that we see. Right, so the area of a watershed reflects the volume of water that can be generated from rainfall. So if you'll notice, the drainage basin for the Mississippi River watershed, which includes not just the Mississippi, but the Missouri, the Arkansas, and the Ohio rivers. Water that falls within that boundary eventually makes its way to the Mississippi River. A watershed can have a length. Now, it's measured in different ways because watersheds have these crazy shapes. So you can measure it at its widest point. You can measure it from the mouth of the river to the source of the river. You can even measure it from the mouth of the river to the farthest point. But usually we talk about the length in terms of the principal flow path of the river. The slope of the watershed will also affect how quickly runoff gets into the river. So, of course, different watersheds have different slopes depending on whether they're in mountains or plains areas. Um, a steeper slope will have a higher velocity of overland flow. A steeper slope will have higher erosion potential, and likely will affect the wind systems also, which have some effect on what's happening in that watershed. The fourth property in a watershed is the soil types, but we're going to look at that when we look at types of watersheds. The vegetation that's in a watershed makes a big difference to the behavior of that watershed. So organic matter is added to the soil when there's more vegetation. Tree litter protects the soil surface and prevents erosion. Roots also hold the soil together and prevent erosion. Tree canopies keep the water cool, and that helps keep certain fish, whatever their zone of tolerance is for temperature. The canopy also reduces the force of rain and wind velocity, which helps prevent erosion. Plant cover provides food for organisms as well as protection. And then finally, we have what's called a riparian zone. So the riparian zone buffers water from runoff. So runoff tends to include chemicals, right? If we talk about agriculture and we put fertilizer on those fields and then the rain comes and it picks up the excess fertilizer and carries it to a river, the bigger the riparian zone is, the less of those chemicals actually make it to the river. So, a good riparian zone is important for streams and rivers. So watersheds have divides between them and other watersheds. These divides are created by mountain peaks, hill peaks, ridge lines, and the water on one side of the divide goes into one river or stream, and the water on the other side goes into a different river or stream. So you can have large watershed divides. You can have smaller divides for tributaries. But generally, if you're looking at the topographic map, you're connecting the highest points on the map to find the divides between watersheds. So some agricultural watersheds start out as barren fields. Maybe the soil is compact, less infiltration, not as many streams. But as we apply fertilizers and manure, that changes the structure of the watershed. Urban watersheds, the natural water flow has been greatly altered due to buildings and impermeable surfaces. It can be highly vulnerable to flooding because when the water falls on the ground, it doesn't have anywhere to go if there's too much asphalt or too many buildings or houses. In these urban watersheds, the land use is fixed, and really, changes in precipitation, matter to how much flooding or not there is. Mountainous watersheds have steeper gradients and less porous soil because it's more rocky. So there's less infiltration and then higher amounts of runoff. Downstream areas here are fairly vulnerable to flooding because of the high runoff and the lack of infiltration. Forest watersheds, there's a fair amount of evapotranspiration because of the high amount of plant life, fair amount of infiltration, and very little runoff. You can see here a little cross section of sort of a mountain and a forest, watersheds where there's precipitation in the mountains, there's runoff from the snow into streams, and the transpiration happens a lot more in the forest area. Here it does show some absorption of the water into the ground, into groundwater, and then groundwater can go to the lake also. Desert watersheds, the soil is fairly porous and sandy. There isn't much rainfall anyway, and so there's very little stream development because what water happens tends to infiltrate quickly. However, the lack of rainfall limits the amount of groundwater recharge. Coastal areas tend to get more rainfall because their proximity to the ocean and higher humidity, but there's less channel control. There can easily be local flooding due to storms, and the water table is pretty close to the surface. Sometimes you'll see saltwater intrusion into drinking water aquifers here, where if your well is too close to the coast, then salt water can get into the well if you pump the well too much, and that will basically ruin the well. Wetland aquifers, obviously water is not a limiting factor here. There can be a high amount of rainfall, but also a high amount of runoff, and then evaporation is the dominant process here as part of the water cycle. It's possible for watersheds to have mixed use if they're large enough, right? If you look at the Mississippi River watershed, of course, there's both mountains and rivers and estuaries and urban areas and agricultural areas. So if you expand your watershed to a large enough area, then you'll see lots of different types of watersheds, like smaller watersheds within the larger watershed. One major effect on watersheds are dams, and we will come back to dams a little bit during energy resources. But it's worth thinking about what happens to a watershed when you back up the river, when you put a dam there and prevent the water from going downstream. So what is the effect on the watershed that's upstream from the dam? What are the effects on the water or the watershed downstream from the dam? So put some thoughts to that and be ready to talk about it. Human settlements also tend to happen a lot around floodplains, right? Sort of these lower area watersheds. And so, why do humans seem to settle on places that tend to flood a lot? It's really not because we like flooding, but a lot of the flooding deposits nutrients in the soil, recharges that soil, and makes it good for agriculture. And of course, rivers can be a source of fresh water themselves. So even though floodplains are sometimes dangerous, Humans like to settle there because of those advantages. Let's say you want to build a house really close to a stream. It looks very bucolic and pleasant, but what are some of the issues here? Where are you going to get your drinking water from? Um, what could happen to the stream that would affect your house or your ability to live in that house? All right, well, that is Unit 4.6, Watersheds. Please let me know if you have any questions.